Hi, welcome to this lesson on statistics, mixed exercises part 1. Let's have a look at question 3. A mathematics teacher was curious to establish if her learners' mathematics marks influenced their physical science marks. In the table below, the mathematics and physical science marks of 15 learners in her class are given as percentages. So you can see they've labeled X and Y for you. So X is the independent variable. And if you read the context of the question, you could have seen that mathematics is the independent variable because the teacher is wondering if the mathematics marks is influencing the physical science marks, meaning that the science marks are somehow having a relationships, are being dependent on what you get for maths. Okay, so learner 1, for example, when they got 26% for maths, they got 34% for physics. Learner 15, when they got 85% for maths, they had 80% for physics. And you're actually given this scatter plot of that 15 data points there. Just based off this scatter plot, based off the geometry, we can actually make some observations that will be backed up by our algebra using our statistical tools. Basically, the data is clustered in a way that it looks like a straight line will approximate this data pretty well. And because of the shape of the data, it looks like it has a positive correlation coefficient. And because the data points are quite close to each other, I would say this is either a strong or very strong positive correlation. Meaning that if we do this right, if we do the algebra for the statistics correctly, we would probably come to the conclusion that the mathematics teacher would also come to. And that is, yes, the mathematics marks do look like they influence your physical science marks. Meaning that if you do well in maths, it probably looks like you do well in physics. If you're not doing so well in maths, it looks like you're not doing so well in physics. All right, but those are assumptions we're making. We have to back that up with some sort of statistical evidence, and that's what we're going to do now. Okay, so first of all, determine the equation of the least squares regression line. So again, that's going to be of the form y hat equals a plus bx, and we can work out those a and b parameters. So on my calculator, again, I'm going to go shift clear everything to get a good fresh start. Okay, so mode, stats, number 2 for regression. And now let's put in our marks very carefully. 26, 62, 21, 33, 53, 76, 32, 59, 43, 43, 33. Okay, so I'm running out of space there, so let's move across there. Okay, then it's going to be 49, 51, 19, 34, and 85. So notice I have 15 data points, which is good because that's how many learners were observed in the study. Also, something to note, while we've been doing all of these exercises, nowhere did I actually ascend the data from increasing to decreasing order, because that's not necessary when we look at this. All right, so for now the y values, make sure again we associate them correctly. 26 goes with 34, 62 goes with 67, 21 goes with 28, 33 goes with 46, 53 goes with 65, 76 goes with itself, very nice, 32 goes with 26, 59 and 73, 43 and 50, then 33 and 39, 49 and 57, so let's just move it across over here. 51 goes with itself, nice. 19 goes with 24, 34 goes with 41, and 85 goes with 80. Notice immediately there, thank goodness I'm looking at all my typings, that's 88, should be 85. So again, you can see how easy it is to mess this up. So if you are speeding through these beginning questions, you are bound to make a mistake. So just take it slow. Double check that you put everything correctly, and then once you're happy, AC, clear everything off your calculator. It's got it saved now. So now I can work out the A parameter. So I'm going to go to regression A. That's going to be 9.5 to 2 decimal places. And then my B value is going to be shift stat regression B. And it's going to be 0.91. So plus 0.91 to 2 decimal places times X. Okay, so that is the least squares regression line for the data. Now they want us to predict the physical science mark of a learner who achieves 69% for maths. And again, 69% is reasonable within this data. Right, so there's 69%. So what do we predict the y value is going to be over here somewhere? So again, I can use my least squares regression line. So I'm going to click 69, shift stat regression y hat. and that gives you 72.22. So therefore, when x equals 69%, the y hat predicted value is 72.22%. Okay, and if you look at your scatter plots, that looks pretty reasonable, 72 somewhere around there. So it looks reasonable. Okay, so that's one of your predicted values. Write down the correlation coefficient, so that's the R value. So again, on my calculator, I can go shift stat regression, choose R, and I get 0.95 to 2 decimal places. So again, that's a nice value, it's very strong, and it's positive. So comment on the strength of the correlation. It is a very strong positive correlation. Okay, so a very strong positive correlation. What trend did the teacher observe between the results? Well, again, like we said, because it has such a high or very strong positive correlation, that means we can conclude that students or learners who do well, so who do well in maths, tend to do well in physical sciences. Right, so some explanation along those lines. You could also argue the contrapositive, which means that if you don't do well in maths, then you don't do well in physics. As long as you note that sort of relationship between them in some sort of sentence structure, then that is acceptable. All right, so that has been using the scatter plot here, using the table for our least squares regression line and for estimation here. Awesome. I'll see you in the next one.